Hello everyone, pleasant day to everybody. Myself, Sony Jenusha, working as an assistant professor in the Department of Electronics and Communication Engineering from Kamaraj College of Engineering and Technology. So today I'm going to take a very interesting topic, that is ensemble learning. So before diving into the topic, let me give you an example. So consider a cricket team consisting of 13 members who are best batsmen. Can the team win the trophy? No, it's not possible. So a cricket team must contain batsman, a fielding and the bowler. So a team must always have a balancing. So all these three must perform well to win the trophy. So similar way, let me give you a definition of ensemble learning based on an example. So ensemble learning in a machine learning technique that combines multiple individual models to create a more robust and accurate predictive models. So it consists of multiple models, so to create a very predictive model so that we can get a best output. So it can be used for classification kind of problems and also for the regression kind of problems. So instead of relying on a single model, if we rely on 2 to 3 models and combining it to a meta model, we can achieve an accurate result. That's why we will be using this ensemble learning. So as we know, we have plenty of algorithms in each learnings. So from supervised learning, we are having decision tree, random forest. So each algorithms are used for a particular applications. So if we know the inputs, what we are going to give as an input and what we want to get as an output, if we know that clearly, we can combine 2 to 3 models, that is 2 to 3 algorithms, and we can achieve an output. So for example, so this is a block diagram for the ensemble learning. So first we will be giving the input training data, then we will be combining model 1, model 2 to n number of models. So we can combine n number of models here. Then from each models we will be getting a predictive output from each models. So all those predictive outputs are combined together to form a meta model. So from that ensemble meta model, we will be getting, using the techniques like averaging and voting, we can predict the ensemble prediction, that is the final output of the particular input we have given. So this is the block diagram for ensemble learning. So what are all the benefits of ensemble learning? So as I already mentioned, the benefits of ensemble learning are improved accuracy. So rather using a single model and couldn't predict the output accurately, we can use the 3 to combine multiple models and we can get a higher predictive model outputs. The second benefit of ensemble learning is reduced overfitting. So in ensemble learning, we can use the bagging, boosting and stacking kind of techniques that will help to reduce the overfitting of data into the models. So the next benefit is robustness. So by leveraging the multiple models, we can achieve the robustness of the data by reducing the noisiness from the data. The next is flexibility. So from this ensemble learning, we can achieve classification kind of problems, regression kind of problems and also clustering of problems. We can achieve all these three in this particular learning. So how it works? As I already mentioned in the block diagram, it works based on the multiple models. First, we have to create the multiple models, that is we have to combine the multiple models by what inputs we are giving. So then from the combined model, we will be achieving an output. So from that output, the predicted output, we have to combine it and use the techniques like voting or averaging to predict the output. So let me give you an example for classification kind of problem. So consider I am going to watch a movie and I want to get a review from 3 of my friends. So friend 1, friend 2 and 3. So I am asking my friend 1, so I am going to watch so and so movie, can I go and watch? What is your point? So he is giving his review about the movie, saying, yeah, you can go and watch, it is a wonderful movie, yeah, you can go and watch. So my first friend told me you can go and watch the movie. So I am asking the review to the second friend. So I am asking it, is the movie worth the watch? Can I go and watch? So he is saying that no, it is not worth it, so you don't waste your time. So he is saying no. So I am going to the other friend, the third friend. So I am asking his review. So can I go and watch the particular movie? So he is saying, yeah, it's kind of boring. The second half is kind of boring, but first half is worth the watch. So he is saying, yeah, you can go and watch. So he is also giving me, yeah, you can go and watch. So this kind of classification problems, I will be taking voting. So I got voting from all my 3 friends. So from this, I will be taking the majority of the vote. So majority of the vote I got is yes. So I will be going to watch the movie. So this is classification kind of problems. So based on voting. So I will get the approval from all the 3 friends, and from that the majority vote I will consider it as the answer. So majority here I got is yes, so I will be going to watch the movie. So this is classification kind of problem. So let us see another example, that is heart disease prediction. Here is also it is a classification kind of problem. I will be using the voting technique. So consider I am building a model using 3 algorithms, that is decision tree, the next one is SVM, the next one is random forest. So I built the models, okay. I used 3 combinations to build this particular model. So I have given an input image, so I am asking it to detect whether I have the heart disease or not. So first the decision tree is saying I am getting as an answer no, you are not having the heart disease. From the SVM I am getting as an answer yes, you are having the heart disease. So from random forest I am getting the answer as no, you are not having the heart disease. So I have got 2 no's and 1 yes. So this is my combined methodology, and I got the predictive output from each of the algorithm, from each algorithm. So from this I have to form a meta model. So I got no, yes and no. So here I will be using the voting technique again, because this is a classification kind of problem. So majority I got as no. So my final answer will be no. So the particular data you have given is the particular patient doesn't have heart disease. So this is the another example for classification kind of problem in ensemble learning by using voting as a technique. So next we will be moving on to regression kind of problems. So as we all know, what is regression is, it gives us the exact value of the particular data. So I want the exact result of the particular data. So I will be going for averaging method. So here also let me give you an example, car prediction example. So suppose I want to buy a car, that is a used car. So consider it as whatever car it is. So I have to buy a car. So I am going and asking 3 dealers. So for a particular car model, so example for Honda City, the second hand car, I am going and asking what is the price of the car, and how many kilometers it has run and how many owner it has. So, I am getting all those data and giving into, again I am building the combined model, that is SVM, decision tree and random forest. Okay. So, here the SVM, that is dealer 1 says, yeah, you can get the car for 1,50,000. The dealer 2 says, you can get this car for 3 lakhs. Then the dealer 3 says, yeah, you can get the car for 2 lakhs. So, based on the other all characteristics, I have taken consider all these 3. So, the first part is dealer says you can get the car for 1,50,000, and the second one says you can get the car for 3 lakhs, and the third one says you can get the car for 2 lakhs. So, in this I will be using the averaging technique. So, average I will sum all the 3 results. So, here I will be summing all the 3 results, that is 3 to plus 2 plus 1. So, 6,50,000. So, 6,50,000 divided by 3. So, from this I will get okay. So, randomly around 2 lakhs around I have to buy the car. So, around 2 lakhs means I will be going with random forest or the SVM. So, this is the averaging technique. So, in averaging technique we will be using 3 to 4 models, that is one is averaging, that is we will calculate sum all those 3 values and divide it and we will get the output. But in next this is minimum value. So, from all the meta model result I will be taking the minimum value as my output. So, here my minimum value is from SVM. So, in the minimum model I will be taking SVM as my output, that is 1,50,000 I will purchase the 1,50,000 car. The next one is maximum. So, maximum means the maximum data I received from a particular model, predictive model, I will be taking that as my output. That is, here the maximum model is from decision tree. So, maximum model I will be taking as decision trees, that is 3 lakhs worth car I will be buying. So, here we can use the next method is median. So, median is I will arrange it in a ascending to descending order, that is 1,50,000, next 2 lakhs, next 3 lakhs. Then I will consider the median values, that is the center value as my output, that is I will consider random forest as my output for median. So, while averaging based on the output we need, we can select any 4 things. We do have a weighted averaging and all. So, today we will be seeing only these 4 averaging techniques. From these 4 averaging techniques we can analyze what output we can need and how it is predicted the output. So, with this I would like to conclude my today's lecture. So, thank you for patiently listening to my today's lecture. So, I wish you all have a great day. Thank you.